Hi, and welcome to the second tutorial on C Beginner to Pro. Today we'll be dealing with the actually interesting stuff of getting into the code. As for an example, here's the classic Hello World program written in C. Now, if you run this program on your chosen compiler, like let's do the GDB online for now so we don't get too confused. If you run it right now, you will get the output down here. It's just going to say Hello World. This is just the standard program that every tutorial starts with, the Hello World. It's a classic, so I start with it. But let's look into it and see what is actually going on here, starting with each line. First, let's ignore the very top one, which is the hashtag include stdio. You don't need to know what this exactly does for now. Just know that you sort of have to put it on top. This will be explained when we talk about the macro processor, how it works, what it is, etc., etc. So let's start with the first line of interest. That is the void main brackets. Now, every C program needs to have one function, that's main, the void main. Also, you could have int main, but for now, let's just think about void main. Every C program needs to have exactly one of this. This is your entry point of the program. This is where your program starts. So everything will start from here. As I explained in the last video, C code is executed imperatively, so line by line. So first we were going to do the first line, then the second line, and then so on and so forth. We are not dealing with conditionals and switches and things like that, where things are a bit more interesting. For now, we just deal with the very straightforward code execution. So line by line, starting with this line, as I said, one line of this per your program. If you have more, C will complain. It will cry about it. So what this does is it basically defines a function. Specifically, if we look further on in the tutorial, we'll see how functions are defined. The next line that's going to be executed, for this example, I wrote two lines. So what this will do is actually it's going to print first program, then on a new line, hello world. So the next line is just going to print, and then once it's done with this line, it will go on to the next one, which will print the hello world, and then it will go to the next line, which will be the closing bracket, and this will say, okay, this is the end of the function. Since this is the main function, this will also be the end of your program. So if you have reached here, your program would have exited. As you can see here, it exited with status code 0, which means everything was fine. It reached the end of bracket of the main function. Everything was fine. Great. So there's two things that I think you should pay attention to. That is the semicolons and the brackets. The semicolons define an end of a line. So whatever you do, you have to add a semicolon at the end of it. That's how C says, okay, this is the end of my instruction. From here on out follows the next instruction. Because of that, there are some interesting things. If you've worked with Python, for example, you don't write the semicolons at the end because each line is defined as an instruction. In C, you could have all of your program written on one line. But yeah, you write the semicolon at the end of every sequence of instructions. So for example, int a, we'll see what this does. It basically defines a variable of type integer. So this is whole numbers are integers. They can be positive, they can be negative, but they're whole numbers. So this is defined it, and then we write the semicolon, which means, okay, you're going to the next instruction. Then we are defining float pi equal to 4.0. Of course, this is an incorrect estimation of pi. We're engineers here. We're estimating, we're rounding up a bit. But what float is, it's a floating point. It's basically your not whole numbers. So you can have real numbers there. You can have fractions. It's basically just fractions. So we've defined a fraction. It's a very boring fraction since it's 4.0. We could also have 4.1 here. Could have 4.2, doesn't matter. We say the semicolon, that's it. I'm going on to the next line. Next line is going to be printing again the hello world. We reach a semicolon again, which means end of this instruction. And we don't need to write semicolons after the brackets. C usually shouldn't complain about this. There might be some forms of it that might complain, but you don't need to write it. It's fine. As I said, you could write your entire program on one line. So this is the program we saw in the beginning with the void main print first program, then print hello world. Printing is basically just writing it over here to the terminal or whatever you define it. But for now, we're defining it as in printing to the terminal. So it will just output whatever text we put in here. How printf works exactly, we're going to look in greater detail in a second. So this is what just printing does. You can have your whole program on one line. This is the exact same program as before. It will do the exact same thing because, as I said, you just need to have the semicolon as your separator between instructions. If you don't have this semicolon here, C will be like, okay, well, I don't understand what this printf brackets printf is. The program will just like not compile. Let's try it again. Let's actually try it to write something like that. So as before, we have our printf, which is just printing a sequence of characters, which for us was first program. Then we had this weird thing which just means new line. So if we run this, you're gonna see it says first program, hello world. There should be a new line here. This adds automatically a new line at the end, the online GDP. Once we start working with the actual compiler, that's our GDB compiler, you're gonna see that you need to put new lines here. But for now, don't think about it too much. If we remove this semicolon, the C compiler will complain, will be like, oh, I expected you to put a semicolon before this. It's a bit smart, but sometimes it can be incorrect in what it's telling you. But basically, you can interpret this as, oh, there's a semicolon missing. Basically, get in the habit of writing your code like this, line by line, and at the end of every line, a semicolon. Just for the sake of it, let's try it. If we put a semicolon at the end, see, everything's fine. As I said, you don't need it. Here, we remove the semicolon, everything works just fine. Now, we can do the other program where we defined our thing like this. There we go. As for the brackets, we're going to see in a second, they can also be on the same line. This is just a matter of preference. And this can also go there, as we saw in the example. It's all the same program, does the exact same thing, which can lead to a few funny things, such as you can have your whole program written in a very weird style, such as the infamous donut program. So as you can see, the code is written in the form of a donut. And as you can see, it generates a spinning donut. It's a very famous code example. You know, one day, actually by the end of the course, you might actually quite easily do things like that. The math behind this is a bit more complicated, but strictly from the programming point of view, you will be able to do things like that. Anyways, let's go back to our original program. That was our, hello world program that just prints, that writes hello world there in the terminal. The black thing at the bottom that we saw is called the terminal. Just a bit of a terminology if you're not familiar with it. So it just writes hello world. As we said, the very first thing, void main, is a function, and it's a very special type of function definition because we have only one main. If you don't have a main function, your program just basically won't do anything because C starts from your main function, from the first line of your main function. So let's see, how do you define a function? You basically define it in this type. You have the first part, which is what return type you have. We're going to check out what return types are in a second. And then the function name. You can put whatever function name you want here. Doesn't really matter. As long as you don't put space bars and certain forbidden characters. As long as you stick to alphanumericals, you're fine. You can also add underscores and a few other symbols. But there are some symbols which you can't use in functions. But for now, just think, I write alphanumericals in here. So this means alphanumerical means letters and characters, whether they're upper or lowercase characters, doesn't matter. However, it does matter once you start calling the functions. So for example, if you have a function called void ccc that does nothing, and then the void ccc with capitals, these are two different functions actually, if online GDB understands that. Yeah, as you can see. However, if we do this again like this, this will complain because it will say, oh, this is a duplicate. So you're defining the same function name twice. I am getting a bit confused. What is going on? That's what GDB will complain about. But anyways, let's look at what return types are. Or you can also call them primitive types. You can have more return types than primitive types, but for now we'll look at the primitive types, which are the very basic types you can have in a program. Starting with the smallest one, which is char, which is 1 byte, so 8 bits. What are bytes and bits is going to become clear in a second. So char or char stands for character. So with this you encode characters. So if you look at over here, the ASCII table, with each character there's a corresponding number to it, and that's basically how you encode characters in C. We're going to take a look at it in a greater detail in a second. Then we have int, as we said, integers. They're greater or equal to 4 bytes. For now, just know that you can encode quite a variety of numbers to it. I think, if I'm not mistaken, it's from -8 billion to +8 billion. Somewhere around that range you can encode. Then you have shorts, which are probably the same length. The reason I say probably is that C can have different sizes of the thing. So for example, on some machines, int, so integer, may be quite larger. On others, it can be slightly smaller, but it is always at least 4 bytes or 32 bits. Then you can have, on top of shorts, longs, which are always larger than integers. So with them, you can encode a lot more information, a lot larger numbers. And then you have the floats, which, as we said, are your floating point numbers or your fractions. So like things like 37.345, so on and so forth. While everything above is basically this int, short, and long, encode whole numbers, whether positive or negative doesn't matter. Float encodes fractions, whether positive or negative doesn't matter. You can encode -3.6, +10.5, or whatever. And double is the same as float, it just can hold larger numbers. And then we'll see that you can also make pointers. What they are doesn't matter right now, but they're also a type of primitive. And then you have void, which you've seen until now, which basically means nothing. So what this means, if we go back to the slide, we can have here integer main, which, well, actually, let's call it something else, int AAA. Let's see an example. Actually, let's write out an example. So let's make a function int a. Oh, actually, no, let's make it something more fun. In sum, because we have written int in the beginning, this means we need to have return, which basically means this is the end of the function. As the end of the function, I will return to whoever called me this value. So let's return 5 + 4, something like this. Or you can have char here. So this defines your return type. Then you would return the character, let's say A, or the character lowercase b, or the character 7, or the character underscore, for example. Doesn't matter. So the first part just basically defines your return type, while the second part is just the function name. As we said, in the function name, you can put pretty much whatever you want, as long as you stick to numbers and characters. Right. So we talked a little bit about bytes and bits. If you're new to programming, you might be a bit confused about what they are. Basically, it is representations in the computer. As you know, the computer works with ones and zeros. On an electrical level, it just means something is off or something is on. So these are examples of bytes. So each byte is 8 bits, where a bit represents either on or off. So 0 means off, 1 means on. And you can have different variations of them. These are all examples of bytes. As you can see, 8 little bits, and you can have, if you know how math works, for each you have 2 options. So each can be either on or off. So this can be on or off, this can be on or off, this can be on or off, like so on. So you have 2 to the power 8 values that you can hold in a byte. 2 to the power of 8 is 256 values that you can store. So as we said, a bit is either 0 or 1. It's can encode a single digit, so 1 or 0 actually. It can mean false or true. So 0 meaning false, 1 meaning true. So are you telling the truth? Yes. 1, 0, no, I'm not telling the truth. Is the sky blue? 1, the sky is blue. Is the earth flat? 0, the earth is not flat. Or it can mean, oh, this is off, this is on. It just depends on how you interpret it. It's just off or on. And from then on, you can read it or encode it in different formats to mean different things. And then we have bytes, which is a combination of 8 bits. So 2 to the power of 8 combinations for a byte. It can encode, as we said, different information. So for example, if we return here to the code, if you take, for example, the character A, it has a certain byte representation, which is equivalent to 97, or written in binary. So you have 0, 1, 1, 0, 0, 0, 0, 1. If I haven't got, yes, it's a byte. So A is actually, the character A is actually encoded inside of your computer if you're using, of course, ASCII, which is 1 byte per character is encoded like this. So your computer has this inside. It can interpret it as A, or you can say, oh, actually this thing, you should now read it as an integer, so it's going to read it as 97 because of something that's going to become clear right now. That is how you can read bytes as numerical values, because as we say here, they're read in a binary system. For example, we normally in the daily life we use a decimal system. What this means is that each number, so for example 97 that we have here, this means 7 plus 9 times 10, right? So this is what 97 means basically. This is autofilling things that I don't want it to. If we take the number 139, this means 9 plus 3 times 10 plus 1 to the power of 1 times 100. What this means is also, if you know how powers work, what this means is 10 to the power of 0, because anything to the power of 0 is 1 with some exceptions. Then 3 to the power of 10 to the power of 1 plus 1 times 10 to the power of 2, and so it progresses like that. That's how you read the decimal system, right? So the binary system is the same, except instead of 10 here you have 2. So if you take the number, let's say 110, also in any system you cannot have a value that's larger than your system. So binary is a 2-based system, right? So you cannot have the value 2, just like in decimal you don't have anything that represents the number 10. In, let's say, a base 12, which is a base higher than 10, you would represent 10 as A. So in base 12, if you want to write A, if you want to write 10, you will just write a capital A. This might be a bit confusing if you've never dealt with different bases. I will provide a video description and an article like that you can briefly read to familiarize yourself with how they work. But for the sake of this video, you don't need to care too much about it. So a byte is also what the smallest addressable size is on modern machines. So on your computer, you cannot modify bits by themselves. You always modify a byte because it is too expensive, as we'll find out in later chapters, to modify every bit by itself. So you just modify the whole byte, even if you change only 1 bit inside of it. Right, so here's an example, which we have 11001100 as a byte. What this means is you have 0 times 2 to the power 0, then you have 0 times 2 to the power of 1, 1 times 2 to the power of 2, which is 4, then 1 times 2 to the power of 3, which is 8, then 0 times 2 to the power of 4, which is 16, 0 times 2 to the power of 5, which is 32, 1 times 2 to the power of 26, which is 6 to the power of 6, which is 64, and then 1 times 2 to the power of 7, which is 128, giving you 128 plus 64. This makes 192, if I'm not mistaken my math, plus 8, that's 200, plus 4, that's 204. So this number here in binary is equivalent to 204 in decimal. Now also, if you work with computers, you'll find another representation of numbers, which is here on the right. This is hexadecimal, so it's base 16. As we looked, you can have bases that are higher than 10, and then you use characters to encode numbers that are higher than 10, because you don't have, because in base 10 we have only until the digit 9. We have 10, which is now 2 digits, and we want a single digit to represent both. So you would go A to be 10, right? B then becomes 11, and you get the point until you get to F, which stands for 15. because as we said, you don't have a representation of the base number. So in base 10, we don't have a single digit to represent 10. In base 16, we don't have a single symbol to represent the number 16. So the number 16 there becomes just 10 in hexadecimal. So this is the other representation you might see in computers. So as you can see, these are equivalent. A quick way to transform between the two, if you have a byte, is to split it in two, and then the right side is one character. So this is 1111, which is 15. So this becomes F, and this is 0, 0, 0, 0, 0, which is 0. So it just becomes 0. Again, split this into 10, 10. This makes 0 times 1, so 0 plus 2 plus 0 times 4 plus 1 times 8, so this is 8 plus 2, 10, therefore we have the A here. And then the second part is 0 times 1, 0, 0 times 2, 0, 1 times 4 plus 1 times 8, this is 8 plus 4, 12, which is C. You know, it just takes some practice to experiment between the two, and I think you'll get used to it. For now, doesn't matter too much. Just, yeah, this is what bits and bytes mean. We will have a whole video dedicated to them, but for now you just need to have the basic idea of what a bit and a byte is. As we said, this is your function, how you define it. So these are your return types, which are for now just primitive types. So you can return characters, you can return integers, you can return shorts, longs, floats, doubles, pointers, voids, etc., etc. So let's look at some examples of functions. You know, we have the classic void main that we've seen until now. Then we have InSum, which returns 1 plus 2. So as we said, what this return keyword does, it says, okay, this is the end of the function. Once the function has reached this keyword, it will stop. So this function will stop executing, and it will, as the function says, return back to where you were called, and it will return the value that's here. So this value will now be accessible after the return to whatever function called it. These terms I will explain right now in greater detail. So what calling a function means is that we, for example, let's take our example from there, int sum that was returning 1 plus 2, right? So this is our function. Let's run it. Everything's fine, so there's no errors in our code. Let's clear this out, and let's print right, the double quotations, and now if you want to print a number, what you do is you do %D, for this is how you print integers to printf, and then you do, after you finish writing your thing, what you would call a string actually, which is just, you know, a sequence of characters between the quotation marks, you do a comma, and then you do whatever you want this %D to be replaced by. In our case, we want to call sum. We call a function like this, so we do this to call a function. What this does is it will find any function with this name, and it will start executing it, you know, sequentially, similarly to how we executed main, line by line, going into the first line, which in our case is just return 2. So let's make it more fun, just by printing here in function, right? And then the new line symbol, which is /n. I will explain this in a greater detail in a second, but for now, right? So what this will do here, once we reach this line, we will jump to here, and we will start line by lines. First we'll print f, and then we'll return the result of 1 plus 2. So this will return 3 essentially. It's equivalent for now to write 3 in here, and then it will return here back to here. For now we don't do anything with the value returned, so it can just as easily be ignored. And then we go to the next line, which is just printing this number. Actually, let's do here. So it will write return, and then whatever's in here by sum, right? What did sum return? It will replace whatever is returned here with this. So let's run this. Yes, so what is it complaining about is here it's giving a warning that technically we should first put sum here, because here, once it goes here, it doesn't know what sum exactly is, but the compiler is smart. Technically, you should first define things, in order. Yeah, I'll explain this in a second. So why did we see in function printed twice? Well, we get to here, we print in function and we return. And then once we're in here, what we do is again, we call sum to get its result. So we go in here, we print in function, and then this time we do something with whatever's returning here, which in our case was 3. So we do return 3 by sum, right? So this is what return does. It stops. So if we have anything after this, so if you want to print in function here, this line of code will not be reached. And yeah, as you can see, we don't see in function again. But if we move the return 1 plus 2 after it, we will see in function again, in function again, right? Because whatever comes after the return doesn't matter. Our code for the function stops at the return, right? So as a special case, you have the void functions, which is, let's call it AAA, just for no reason. For them, of course, since void means nothing, you don't return anything from it, you just do return this. So you don't return anything from it, you just stop the execution of the program. If you try to return something, well, actually, let's first demonstrate that this works fine, right? But if you try to return something like return 5, see, it will complain. It will say return with a value in a function that is returning void. So in a function that's returning nothing, you're trying to return something. For now, it's just a warning because C is very loose, as we said in the first video. It's basically saying, okay, you probably know what you're doing, but it's warning you that, hey, whatever this is, you'll never see it. So this will return nothing. So this 5 will just be ignored. Is what it's trying to tell you, the C compiler. Anyways, to return to the slides. You can define different functions with different return types. We saw sum. We can return characters, as we saw, which is just, this returns the character A to whatever it was called by. Right? We can return floats, so this will give us a better approximation than our former 4. It returns 3.14. Here you can see how you can write out fractions. You can go more than 2 symbols, but there are certain limits on accuracy, which I won't get into now. Or you can return float mode, which just returns 3. Right. Now, functions just by that are kind of boring. They just do a static thing. If you want to make it more fun, you can pass them arguments. So now they become more like, if you've done math, you might be familiar with writing functions like this. So I will write it down here. So f of x, right? This is basically in math how you'd write a function, and then like something like this, right? X to the power of 2 times 3. X to the power of 2 plus 3. So what this basically does is it defines a function which takes as an argument x and then returns this, right? So the equivalent of this in here, because we are going to be returning an int, we'll be writing int f, which will take an integer x. We're assuming that x is expected to be a whole number, right? Which it could be a float, of course, in which case here it would be a float. For now, we're assuming that x would be an integer. And we are returning x times x plus 3. That is, these two things are equivalent. So if you call f of x in mathematical terms, you will do f of 4 is equal to 4 to the power of 2 plus 3. So this is also the equivalent of 19. And you can do the same here. If you call f4 in our C language down here, this will return 19 as well, which we can demonstrate by just cutting this here and putting it over here, and then calling f with 4 here, and then let's write f here. Yeah, see, return 19 by f. And then if we call it with 5, it will return 5 times 5 plus 3, which is 28. Right, return 28 by f. Right, so you can think of functions similar to the functions in mathematics. They're pretty much the same thing. So how arguments work, I kind of put the carriage before the horse. You can have any number of arguments you want. So these are things that are split here with a comma, right? So the way you define it is the argument type first, which is any of your primitives or, any type. But for now, let's think of only the primitive types, which, if you remember, were int, char, long, char, I said char twice, float, double, the same ones that you would return here from the functions. And then the argument name, which would also call a variable. And then whatever you put in here, you can use inside of your function. So to return here again, right? Here we have defined int x, so we can use x inside of our function. If we try to use some other thing like a, like here, C will be very unhappy if we like, oh, what is this a? I have no idea what this a is. Even if we define it in over here, let's say here we define int a equal to 5, so this will define, here int a exists, so to demonstrate this, well, let's call f of a actually, there we go. Right, so we're calling f of a, but because a is not defined in here, C will not run. As you can see, it will say, oh, a isn't declared. If we replace this a with x, we get our former result of 28 because a is equal to 25 now. Right, so whatever you put in here, you can use inside of your function. And you can have any number. So you can have int b, well, let's stick to like more mathematical terms, int xyz. This will do is we'll sum int and then like this. And whenever you call the function, this number of arguments needs to match the number of arguments you're putting in. Just like in mathematics, you would have, fxyz. And if this was how I already defined your function, then if you just called it like this, it will make no sense. So you need 3 arguments again. So let's now do fa3 and then a again. For example, we can use a twice. So what this will do is it would call 5 times 5, 25, plus 3, 28, plus 5, 33. Here we can have 7, oh, well, I wrote 8. So this will do 5 times 5, so 25, plus 3, 28, plus 8, 36. Exactly, returns 36. And you can have a for all 3 of them, right? And in that case, it will just do 35. Or you can have, like this as well, which will do 26. Right. So that's how you can define arguments. So these are basically your parameters of the function that you use. Think of it, as I said, similar to how mathematics works. And they don't need to be the same as your return type. So like, for example, this is a valid function. You have a, which is an integer, and b, which is a character. Perfectly valid function. What's inside the body of the function, so what it happens inside, we don't know. We haven't put anything in here. Well, actually, here's an example. It sums a plus 2, and then we do nothing with the b. It's fine. The b is not used. Perfectly valid function. Even if b is not used, a has been defined, so anything inside here has been defined. There's rules about scoping, which we'll deal with later, which is, for now, you don't need to know what exactly that is. So a quick reminder of the variables. The way you define them, arguments can also be called variables. They're pretty much equivalent, except not all variables are arguments, but all arguments are variables. So variables, you define them like this. You put the variable type first, and then the variable name, and then at the end of the line, the semicolon. You can also initialize them immediately. So you say, so for example, here we have not initialized a. We don't know what value exists for a. We need to later on define it like here. So here what we've defined is we've declared a, then we declare pi, and we immediately assign 4.0 to it, and then we assign 4 to a. Right, so a is now equal to 4. And then you can do on the next line a to be equal to 5, right? So they're variables because their value can vary. So for example, in our main here, we defined a to 5. Well, now let's set it to be equal to 6. So this will change the behavior of this program. So if you remember, if we code it with 3 a's, what it did is return 35, right? And now if just before we call the function, we set it to a to 6. So we change this value. It's 48 because 6 times 6, 36 plus 6 plus 6. That's 48. Yes, and then we can redefine it again to something else. It can be a completely arbitrary number, actually. Let's put 72 there. So yes, you can change their value is the point. Right. So just to familiarize yourself with some mathematical operators that you can use, we've seen the plus. It's quite easy to understand what it does. It's the same as a mathematical plus. Then we have the minus, which is just subtraction. Division is done with this line here. That's the line we use for the division. And then multiplication is done with the star. So if you have variables with the star, yes, you multiply them like this. You can use brackets just the same as in mathematics, as long as the brackets on the left match the same number as the brackets on the right to define an order of operations. And then a special symbol is the percent symbol, which defines modulo. So it gives you the remainder of something. So for example, to return to this function, this code that we're writing here, right? We had int x, y, z. Well, now let's do something more funky, which sums x plus y, right? And then gives you the remainder of division with z. So let's do here 4, 5, 3, 2. So what this will do is it will sum 5 and 3, so 8, and it will give you the remainder by division by 2, which is 0, because 8 is divisible by 2. And if we do 3, because 8 is not divisible by 3, it gives a remainder of 2. It will output 2, which is the remainder of this, right? Should be clear enough. Yes, if you've done mathematics, basic mathematics, this should be pretty straightforward to you. Now, to return back to our main function that we've written until now, we now understand what this line does. It defines a function main that returns nothing and is called main. It has no arguments inside, and then inside of it goes first line, which is printf, which is a function which is included in here, although we have not defined it in here. It's defined in here, the stdio.h. It has a very unique definition, which we'll look into in a second. It just calls the function printf with a parameter that's here. That's a string. So this is a string of characters, a concatenation of characters, a sequence of characters. So the characters he, whatever, and then the special character for new line. So, and what it will do is, as we've seen, it will just print new hello world. So the function printf, just to have some I/O, so input output, so some way to interact with your program to see what it's doing before we delve into some interesting things. Printf, it prints to stdout, so the terminal, or actually you can redefine what stdout would be for, but for now, think of it just as the terminal, that little black thing we saw here on the bottom until now. It can take any number of arguments, actually. It can be as long as it's more than one. So it's a special type of function which can have a variable length of arguments. We'll see later on how we can define such functions ourselves, but for now, just know that. So the first argument must always be a string, so this thing in quotations, and then you can have the escape characters, which means %d for integer in decimals, we saw %c to print a character, %s to print a string of characters, %x to print an integer in hexadecimal presentation, %d in integer in octal. This is not correct, please ignore it, this is a mistake in the slides. %f to print a float point. So just to mess around with the printf function a bit more, let's return to our code here that we have, and let's take this print function, and now by f, and since we want to, let's also print a character, right? And let's add the character d. So this will say return by f, comma, and then d, we can put another character. Characters are single characters, so if I try to print az, it will complain because it's not a single character. It needs to be a single character, whatever that character is. Right. The order of how you put your things here, so you say, oh, this will be a integer, this will be a character. This order needs to be the same as the order they appear in here after the quotation. So first needs to come whatever's first here, second comes whatever's second here. You keep this order, the same order that they are in here is the same order that they are after the quotation. That's what you need to remember, right? And I think that well, maybe we can look into how we can print a string of characters. Like we complain that we can only print one character there. Well, now let's print a string of characters. Strings of characters are with quotation marks like this. So now if we do this, you see we can put more than one character. So fla la la is printed after that. As for the hexadecimal representation, just because we spoke about it, yes, it's not that interesting. So let's do multiplication here, because 2 in hexadecimal is the same as 2 in decimal. Now let's do 8 times 3, which is 24 in hexadecimal. So this will print 18. Not that there's a mistake in our code. It's just that 18 in hexadecimal is 10 in it's 24 in decimal. If you print 10 here, you see the character, lower character a, and if we print 11, you see the lower character b, because that's what 11 is in hexadecimal, right? I think that pretty much expands it on printf. Of course, if you have any questions, feel free to leave them in the comments. I will take time to answer each of your comments. And now let's write some functions of ourselves by ourselves. Let's see what we can do here. Let's do square int square number like this. So what this will do is it's essentially this mathematical function f of x equal to x to the power of 2, right? Which is the same as saying x times x, right? So we want to make this function. So we will be dealing only with well, actually no, let's make it floats. Let's make it floats for a bit more fun. So we will be returning a float, and this is the name of our function square number. And then as an argument, we'll take the float x, right? And then what we need to return is, as we said, x times x, right? And let's verify that we works fine. Let's remove everything from here. Let's clear this out, square number, because this is where we're returning from. And then here we want to say, okay, we're printing a float, so we need to do percent float, square number, and then let's do it of 3.40. Right. Oh, I forgot to clear the fla la la la, sorry. Oh, it's warning that's too many arguments, but the thing still works, right? Because there's one argument too many, because there's no %s equivalent in here for the fla la la la. Actually not fla la la la. So it's just warning us, but it still works fine. Let's run it again just to clear the warning. So as you can see, this returns to us 3.14 times 2. To verify, let's use an easier thing to square, like 3. As you can see, it prints it as a float, so that's why we see the 0.000 afterwards. Let's do 11 for the fun of it, 121. And we can also do negative numbers, so -3 times -3, that's 9. Yeah, same as here. -3.14, sorry, 14,15,928. I think this might be a bit too large for our floating point representation, but that's fine. Not too large, but a bit imprecise. So yeah, great. We've already made one function, which is a function that takes a number and squares it. Let's see, what else can we do? We've already done the modulo thing. So given two numbers, return the remainder between them. So remainder. However, remainder may be defined already by, so let's just call it rem, short for remainder, so as to avoid declaring another function that's defined without our knowledge. So rem, which will take two numbers. That's for the fun of it, call them a1 and a2 for now. It's good to have them, to give them good names, not just single character names. But for now, this is fine, because if you give them more descriptive names later when you check your program 10 years in the future, it's going to be easier for you to tell, oh, this program does this, instead of trying to figure out what A1 and A2 mean. Right. So let's return A1 modulo A2. So this will return the remainder of A1 when dividing it by A2. We want to return a number, so we do the %d. We do by rem. We don't need to do the by rem. I just do it so you have an easier visualization. But if it's confusing for you, we can do it like this. And then we do the rem. Let's say 4 and 2 should be 0. Yes. 4 and 3 should be 1. And then let's do 7 and 5. So remainder 2. Right. Works great. As we said, this is the new line symbol, right? So you can plop it here back to back like this, and then you can start writing immediately after it. So what this will do is it will return, write this, return, and then on the new line. So that's how you can do new lines with the slash, and you can concatenate any number of them. So this will do 2 new lines after the AAAA before it does the next A. Here it's, yeah, so here's new line once, new line twice. So this is, that's why you can see only one new line between the two, because the first new line is consumed to move to here. So, there's a new line here to here, there's a new line here to here, and then there's a new line from here to here. Right. Yeah, so I think this is pretty much the extent to some very basic understanding of functions. You can write some very basic functions. You understand the void main, you understand printf, you understand the primitive types, void, float, int, long and character as well. Right, so let's look into some programs you can do for homework, for exercise. I'll do them myself as well, as I said at the end of the week in a separate video. The first one, a void cube, which takes a float a. So what this function should do, it should print the cube of the float. So for example, if you call cube 3 on the terminal, it should print 9. It shouldn't return anything. The printing should be done inside the cube function itself. Then as for the next function, you do the sub. So what it does is subtracts b from a, as explained here, and then finally say 3, which is going to print a 3 times and then print b 3 times. Sorry, not a, but whatever the value of a is 3 times, and then whatever the value of b is 3 times. Inside the void function, not returning anything by itself. Just to explain how the last function works in a greater detail. So if you call void, say 3 character b 4, it will print bbb space 444. That's what this function should print. And if you do void, say 3.75, it should do ... space 75 75 75. So that's what it should do. These are pretty basic functions. As we said, we are still in the very, very early stages of programming. The stuff we do are a bit more boring. However, it will get very interesting very quickly. And I hope to see you for the tutorial video. And if you want, and hopefully for next week, where we'll be dealing more with functions, more with IO, and with conditionals and loops, where things get a bit more interesting. Basically, after next week, you'll be able to do 90% of programs. So hope to see you then.